All right, so let's work through the solutions for the Assessment 7 review. Question number 1 has the claim that the average SAT score in Maryland in 2018 was 1066. So this is an equivalence statement. So the null hypothesis would be that the mean is 1066, and that the alternate hypothesis would be that the mean is not 1066. All right, so problem number 2 works with a new claim. More than 99% of Garrison Force students have been accepted into at least one 4-year college. Because this is a more than statement, this will be a right tail test. All right, so let's look at number 3. They give you the null hypothesis that P is 0.9. The data suggests that the interval is between 0.75 and 0.85. 0.9 is not on that interval, so we should reject the null hypothesis. Number 4, they give you a null hypothesis that the mean is 29, that the alternate is that it's not 29, and this is the average age of a Major League Baseball player. So the statistical sample tells us to reject the null. Here the null is the claim, so we would say that the sample does not support the claim that average age of MLB player is 29. All right, so let's move on to page 2. Okay, so page 2 says we've got a claim that 46% of American workers claim that they're underemployed, right? So the null hypothesis would be that 46% are. The alternate hypothesis would be that 46% are not. Because this is a not equal statement, this is a two-tailed test. And then we get some data, right? And the data wants us to create a 95% confidence interval for this, so let's get the calculator. All right, so this is a proportion, and we want an interval, so this goes to the 1 proportion z interval. We're given the x value here would be 210 out of 500. We want a 95% confidence interval. So this is going to give us 0.37674 to 0.46326. So let's get that over on the other sheet. Okay, so number 7, the calculator just gave us the confidence interval between 0.37674 and 0.46326. 0.46 is on this interval, so we fail to reject the null hypothesis. In this problem, the null hypothesis is the claim, so the data supports the claim that 46% of American workers are underemployed. All right, so the next claim is less than 5% of Chipotle customers leave the restaurant dissatisfied. So my null hypothesis is that the proportion is equal to 5%. My alternate hypothesis is that the proportion is less than 5%. So number 11, this would be a left-tailed test. And now we have some data that we need to produce a p-value with, right? All right, so in this problem, we're going to conduct a 1 proportion z test. The portion that we're testing against is 0.05. We're told that we have a sample where 17 people were dissatisfied. And we know that the sample size was 200 people. This is a left-tail test. So we calculate this, and we get this p-value. It's really, really high of 0.988. So let's get that over to the other paper. So number 12 was that the p-value was 0.988. 13, because the p is large here, p is bigger than 0.05, we fail to reject H null. Number 14, since this is the claim, then the data does not support the claim that less than 5% of Chipotle customers leave dissatisfied. All right, so for number 20, we have a new claim. Teens get fewer than 7.5 hours of sleep per night on average. So the null hypothesis here would be that the mean is 7.5. The alternate hypothesis would be that the mean is less than 7.5. Because of the less than, this is a left-tail test. And then we get some data. So let's work the game here. It's going to ask us for a p-value from the t-test. So let's do that. Okay, so let's bring up a t-test. And we're testing against a mean of 7.5. The mean in the sample was 6.8 with a standard deviation of 1.2. The sample size was 1,000. And we said that this was a left-tail test. So we calculate, and the p-value actually comes up as 0. Okay, so this is way under 0.05. All right, so for number 22, the p-value that we got here was 0. 23, since p is significantly less than 0.05, we reject the null hypothesis. For 24, the claim is not the null, so if we reject the null, we're supporting the claim. So the data supports the claim that teens get fewer than 7.5 hours of sleep per night. All right, so we have a claim that fewer than 5% of all Americans work 2 or more jobs. So number 25, the null hypothesis would be that the proportion is 5%. The alternate hypothesis would be that the proportion is less than 5%. 26 asks about the type 1 error. The type 1 error is always that we reject the null hypothesis when the null is true, so it would be when the proportion is 5%. And 27 is the type 2 error, which is when we fail to reject the null hypothesis when the proportion is not 5%. Okay, so we have a claim here. It takes a worker on average 25 weeks to find work once they become unemployed. The null... Ooh, I did these in the wrong order. Sorry about that. I did 20 before I did 15. It's okay. We'll get there. So I'm back to problem 15. The null hypothesis here is that the mean is 25. The alternate hypothesis here is that the mean is not 25. Number 16, this is a two-tail test. Then we get some data, so let's use that data with the calculator. Okay, so this one's asking for an interval, so let's go with the t interval. The mean of the data here was 13.1 with a standard deviation of 5. The number in the sample was 310. So we had this interval between 12.541 and 13.659. So let's put that in there. Okay, so number 17 here, the interval that we got was 12.541 to 13.659. 25 is not on that interval, so we're going to reject the null hypothesis, not on interval. And since the null hypothesis here is the claim, the data does not support the claim that a worker takes an average of 25 weeks to find work when unemployed. All right, so sorry that the problems are in the wrong order. Hope you could do the work of skipping around. I will make a note of that when I send you the email about this. I believe that the solutions in print are also in the same wrong order, but we're getting through it. If you have questions, make sure you're emailing or doing the drop-in session, and we'll go from there. Thank you.